Hey everyone, welcome back. This is the last video for the Math 209 course before you start tackling mock exams. And we are continuing where we left off in the previous video, and that is the integrals. So what we're going to learn in this chapter is how to calculate the area between two curves, which is exactly what it sounds like, right? Look at this picture. You have two functions here. You have two curves. You have this blue one, or now is red, and you have this one, and I want to know the area between them. So essentially what this is, okay, is this. You've got two functions. The one that is higher up is what we call, we'll call that f of x. The one that is lower is your g of x. And the area between them, guys, is just the difference between their integrals between 2 points. So x2 and x1, that's just a definite integral. That would be between, let's say, 0 and 1. Okay, so you already know how to do the math if you're watching this video because you've watched the previous one. Let me just show you how to apply the math to a situation like this. Okay, so I've written the 5 steps, but let's start here. Find the area bounded. Okay, bounded means closed off by the graph f of x and g of x. Okay, so the first thing we need to figure out here is which one is higher and which one is lower. And to do that, you need to just plug in a random number. Okay, so let's say we take the number 1. Okay, I'm going to plug in the number 1. Well, actually, sorry, I skipped a step. The first thing you want to do, right, if I follow my steps, is set the two functions equal to each other to find their intersections, right? Because in order for me to find which one is higher and lower, I first need to find where they meet. So we're going to do that. So step 1, we'll do x squared equals 9, right? I set them equal to each other and I solve here. So if I were to square root, x equals plus or minus 3. So I know that these two functions will intersect at plus or minus 3. And you don't have to graph it, but just so you guys understand, x squared is a very basic function, right? It's a parabola. And it basically looks like this. This is x squared. Okay. Like that. And 9 is a constant. So that's like that. That's 9. And you see they cross here at -3 and here at +3. And we want the area between them. So we want that area that I just shaded in orange. So I can tell just from the graph that the function g of x is actually higher, right? In the area bounded between them, closed between them, it's g of x that's higher up. So when I'm going to be setting up my integral, I'm actually going to be doing g of x minus f of x, the higher one minus the lower one, between these two numbers. And when you're setting that up, you always want to put the greater number on top and the lesser number at the bottom. So this is how we're going to solve this question. And from this point on, guys, this is the math we were doing in the previous video. Okay, so let's do that. I'm trying to find the integral from 3 to -3. So integral 3 to -3 of g of x, which is 9, minus f of x, which is x squared. Okay, let's integrate. This actually becomes, remember what I said about 9? It just becomes 9x. X squared would just become x cubed over 3. Okay, so this now has been integrated. And then we start plugging in. So we're going to start by plugging in 3 into this. All right, that'll give us something. And then we'll plug in -3. So it's a definite integral, what we did at the end of the previous video. But you have to set up the equation first. Okay, so 9 times 3 is 27. 27 minus 3 cubed over 3 is 18. So this whole thing is 18. This part here is 9 times -3 minus -3 cubed over 3, 18. So -18. So 18 minus -18 is 36. The area is 36. If ever you get a negative final answer, it generally means you made a mistake in setting it up. You shouldn't have a negative area. I got a positive area here of 36. Okay. Since this looks pretty symmetrical, it basically is telling me that the area here is 18 and the area here is 18. Okay, that little fact doesn't actually matter. This is what we care about.